Hello everybody, my name is Alberto Marquez. Welcome to this video. We are going to discuss briefly R as software and how it came to be and some of the characteristics. It's in response of some of the questions that my students have been asking. So I appreciate your questions and let's review this. At the beginning, in the early years of computation, there was the development of several packages. Here are some of the most successful. In 1968, SPSS, the statistical package for the social sciences, was developed, and it was developed. Imagine back then, the data you had to read was in punch cards, and the software or the actual program you have to run was also in punch cards. So it was a humble beginning in that way, maybe with 30 users, something along those lines. And if we move forward to 2009, IBM paid $1.2 billion to acquire it. You know, it's a trend that companies need and have access to data, and they need now to make good use of the information. A second package is SAS. SAS stands for Statistical Analysis System. Now the full name is SAS Institute. It was developed in the late 1960s as well, developed by North Carolina State University Agricultural Department. Eventually, it was formed as a company in 1976, and in just the year 2000, it was already 1.1 billion. And another package that is very popular and very successful, particularly with capabilities in quality improvement, is Minitab. Minitab was developed at Penn State University from an earlier program named OmniTab, and the OmniTab was developed in 1962 to work in mainframe computers. And Minitab, the mini comes from the fact that it was developed to be used as a standalone for microcomputers or mini computers. Just recently, in 2020, they have released the cloud-based platform. So these companies are doing well, but their software could be very expensive or prohibitive, and everybody has needs for doing something with the statistics. So people with initiative and with the movement of open software, they took into their hands to the development of something that was more shareable. Some of the strengths and weaknesses of open software, which will characterize R, is that it's cheaper than commercially available market software. And this was big part of the motivation to develop this type of systems. Interestingly enough, just like other movements with interesting software, let's say Linux or simulation languages or programs to manipulate images like GIMP, all of these have been created by very skillful and talented people, and more than anything, committed. These people do it out of the passion for what they know and what they can do, and they like to contribute. They probably spend more hours than if they were paid. So the final product could be very, very, very good. Because of the way that the development happens, and they have a clearinghouse in which the versions of the software is tested by many people. Some people develop it, and then many others test it, and being open software, they have license to jump in and fix what it's not functioning. It becomes a highly reliable product, and because not everybody works on the same platform, the software eventually evolves and is ready to be worked on many platforms, including of course the most popular Mac, Windows and Linux versions. The way that open software development works creates some weaknesses because not all the developers are good agents. For the most part, that's kind of protected with the, as I mentioned, with the way that the software is clear and released to the public. Nonetheless, there are some instances in which little problems have happened, and because it's open software, people have access to the source code. Opens the window for people to modify, to do maybe not what it's best. Another thing is that it may not be as user-friendly as commercial software because the intention is not necessarily to have commercial success. In sometimes the development comes from someone who's an expert in some particular obscure statistical methodology that it's applicable only in a very reduced domain, but on the other hand, it may be very powerful manipulating that particular application, and it's only beneficial for people who have a combination between the ability to work with software and that particular domain. Open software don't always come with extensive support. However, in R, the community is so large that you have tutorials, companies that are exploiting the opportunity to explain this, to implement solutions using R, because as I said, people are collecting data, but now they need someone who uses this type of technology to be able to make decisions, models, etc. So particularly what is R? R is a data manipulation software, and with that it means that it does not only does the statistics I'm going to discuss, but it also prepares the data, because many times the data comes with a lot of problems. It's noisy, it's dirty, it has outliers, things that are not consistent, information that in the way that it's collected is not workable for many reasons. Maybe it has to be unified in terms of units, because it may be that something is in metrical system and the other in inches or pounds or something like that. And there are packages specially designed to clear and standardize the information in the way that it's useful. Then it comes the actual modeling, and by modeling I mean mathematical description of the world. What do I mean by mathematical description? Well, first is the traditional statistics that describe mean, the histograms, the standard deviation, ranges, the shape of a probability distribution, things of that nature. And it's just description of how the data looks and what are the values that represent a series of, collectively, a series of data. But further than that, modeling could mean that you can have formulas that represent the world, or more than formulas, a combination of formulas that together can represent interactions between variables, or even interactions through time that represent how a complete system changes in time. Think about it as the classical problem of foxes and rabbits, and what's the population. If the rabbits grow, then the foxes grow because they have more food. But then if foxes grow too much, then they eat too many rabbits, and that has a problem for the foxes because now they have to reduce, and it's a constant balance between the population of the two. Part of that modeling, therefore, allows you to not only describe the current world, but predict the future world. And in some instances, the modeling actually, since we humans are agents and we want to have some level of optimal solution based on different parameters, it could be there's always a cost for what we want to do, and we may want to achieve that at the minimum cost. For instance, the software can be used to prescribe what our actions should be. R has packages to do that. That is one of the highest or most remarkable things with R, is that it has, because it has so many developers, because it's open software, there has been a myriad of packages. Not all of them are as popular as the other, but when we're talking about that there are over 15,000 packages, you cannot possibly learn the 15,000, right? You become a user of some of them because some of them will be particularly attractive to your domain. Maybe some people are working building models that with data translate into the way that fluid dynamics work, and that would be some very particular application that may be totally different from, say, for instance, control chart qualities. And maybe another application could be a process analysis of some kind of illness and things like that. So a little bit about the packages. Packages are a fundamental unit of sharing code. As I said, it's over 15,000, I don't know how many. And packages bundle different data inside the bundle. It has code. The code allows it to build different things. It has data. And the data may be databases or samples or cases that the user can test and practice to see the cases for training purposes. It has documentation, and it has tests. So it's built in a way that it promotes the success of the user if the user works on it diligently. There is something called CRAN, stands for Comprehensive R Archive Network, and that's the one I mentioned, is the public clearing house for packages. That's where people submit the packages for evaluation, for storage and distribution after they have been tested. So there is a very organized process of software engineering associated with R. This is not just a group of people that are improvised. That's why the program has become so popular, because you can rely on it, and it's in general free of access. Of course, this becomes a challenge for the commercial packages, but as I mentioned before, it has its drawbacks, and of course, people will, in some instances, prefer the price of the software. In order to install the packages, all you have to do every single time is install right on the console, install.packages, and then the name of the package that you want to find. And of course, you can always search on the internet for the most adequate package, and with 15,000 or more, probably you will find more than one package that actually can perform the computations that you're attracted or you need, or maybe the graphs that you would like to present, or maybe it's a subroutine or sub package that actually needs a previous package, which make the original package even better. So after you install the package, then you need to recall it to be executable from memory, and you do that by typing the command library and then the name of the library, the package. And there is always the possibility to ask for help, and the way to obtain the help regarding the package is just package question mark and then the name of the package, or help and in parentheses the package equals something, which I'm going to mention this later, but you see the implementation of this software, for good or for bad, has different syntaxes to do exactly the same. So at first it can be confusing because we cannot necessarily commit at the beginning to what am I going to do, which one am I going to remember. If I'm remembering its package, then some character in the next, maybe I expect to see all commands in that shape, as opposed to a function and then the package equals something as a parameter. And that becomes a part of the challenge of learning R, but it is that way. So R was originally created to develop statistics. Here we have a very simple histogram, and this would be maybe how it all looked at the very beginning. Nowadays there are packages to do graphics, more than one package to do graphics, and specialized packages to do graphics. So with a need in the marketplace to make analysis of all these information and to learn from it, the software has evolved into developing packages that actually can perform all sorts of work that conveys a story. Nowadays you can the way that we describe statistics is actually telling a story, a history of events, or a logic in the presentation, that since we humans, many of us are very visually oriented, it's easier for us to understand the story or the relation of the data when we look at them graphically. Here are just a few examples of some of the graphical presentations you can create rather fast using the graphic capabilities in R. And more than that is, if you're skillful enough, you can develop your own code for developing your own graphs, because it's open software, and then contribute. And on the other hand, today maybe 15,000 plus, but then within time is probably going to be 20,000 plus. So there is a constant evolution in the power of the software. So particularly the strengths and weaknesses of R is on the strength side, it's open source with all the strengths of open source. It has a vast array of packages, as I mentioned. It has quality plotting graphics. It has been developed to be compatible with other software, so you can execute back and forth from one or the other, from languages like C, C++, Java, and Python. As I mentioned, it's platform independent, like many other open source code, and it has a very strong support network. On the weakness side is that the software runs in memory. So if your computer is short in memory and you have a large data set, you're going to have limiting capabilities eventually. Not as fast as you would be working, say for instance, in Excel, because Excel uses more memory just to handle the presentation of it. You don't have that issue with a simplified interface as the one you have in R. Another weakness is, just as the strength is, you have thousands of developers. The flip side of the coin is that the many packages do not have a standardized command and interface or syntaxes. That makes it, as I mentioned, complicated and difficult for beginners. The other thing is that R could have issues with security for web applications. So you can deploy it for web, but it is not robust. And I'm not an expert in cybersecurity by any means. I hardly know anything at all. But that was a remark that I found in specialized web sites. So as I mentioned, R can be flexible, but that flexibility makes it complicated. Here you have three different things to refer to the same item, which is for a data frame. You can select the first column by just typing the name of the data frame, then $, and then the name of the column, or data frame and inside brackets and inside quotation marks the name of the column. Or if this particular column is the first column, you can just use the sequential number of the column. You know, depending on the context, maybe some of the packages will recognize one way but not the other, and it's impossible to remember or to know which one will work or how it will work from the get-go. So that's why it's important to have a good documentation on the packages and learn from other examples. But it's as I said, you don't have to learn all the 15,000 packages. You learn just a few, and you work it from there. Some of the most useful packages in R are ggplot2, which is used for versatile and elegant graphics. Data table is for data manipulation, as I mentioned before. Dipler is for data manipulation. Tider for data cleanup, as I mentioned before. There is another package, Shiny, for data presentation using JavaScript and CSS, specifically for website and interactive plots, which could be very, very appealing if you have a website and you want the user to interact with your graphs and learn from it. There is Plotly for interactive graphics. There is Neater for report creation, and is used mostly in research, but it is neat because you can execute this package with certain parameters, and you come up with an integrated report that has the input, the output, and the text, and good graphics and everything. So in a way, it works like an editor of your report. It should be very neat. There are packages for machine learning and artificial intelligence like MRL3, and there are others for more classical applications in statistics like classification and regression training. So those are very common packages, particularly in the area of quality improvement. There are different packages and different tutorials you may find. This is one I found very comprehensive because it goes around the DMAIC cycle, and it has examples and how R can be used as the main tool to do the analysis required in Six Sigma initiatives through all these instances. And I think it's a very, very useful guide or sample case on how R can be used. These are some sample images that I grabbed from the website, in which they take advantage of the package and the graphic capabilities of it, including little sections of the code. So users are interested in actually using R and make comprehensive methodologies using the different packages. I encourage you to take a look at this page. There is another package that I found, which is the quality improvement charts, QI charts that with simple commands can build for you your control charts and the chart limits and pick that information, and that in combinations with other tools like Pareto charts, which are also present in QI charts, allows you to identify the sources of variation in order to reduce the variability, because at the end of the day that's what we want to do. So here you have this package, and it may be something you can try. And well, this is the end of this video. As I mentioned, I was trying to address some of the questions that were present in the discussions, for which I'm very thankful. That enriches this course a lot, and this is dedicated to you, students of mine, that have helped me to improve the course. I'll see you in the next video.